Alright, today's video lesson is on chapter 11, correlation and regression. Alright, so first thing we need to talk about is scatter plots. A scatter plot measures the relationship or shows the relationship between two quantitative variables measured on the same individual. So like a person's height and weight. Alright, I can measure those. Both of those are quantitative. I'm measuring it on the same person, so I can create a scatter plot. You guys have probably seen scatter plots, especially maybe middle school, elementary school. It's just basically a dot plot, but you're doing it on two variables. Alright, so here's some examples of what scatter plots look like. Here's a positive linear association. We say it's positive because the slope is positive. It's going up from left to right, and it's linear because it resembles a straight line. Here would be a negative linear relationship because the slope is going down from left to right. And again, we say it's linear because it resembles a line. Here's a weak linear relationship. It is kind of going up, but the points don't really flow in such a nice, pretty line. So we say it's a weak linear relationship. Here's a positive nonlinear relationship. It's nonlinear because it's not straight. We can see that it's clearly curving off. So it might be some other type of function like quadratic or exponential, something like that, but it's nonlinear. And here's another one that is a negative nonlinear relationship. Again, it's negative because it's going down, but it's nonlinear because it's curved. We try to focus on linear relationships because linear relationships tell us a lot about the variables. All right, so if two variables are positively associated, if we say they're positively associated, that means as one value gets larger, the other one gets larger. If they're negatively associated, that means as one value gets larger, the other one gets smaller. And if they have a linear relationship, again, they resemble a straight line when you plot them. Alright, so with scatter plots and with looking at the relationship between the two variables, we have something that we call the correlation coefficient, usually written by the letter R. Your correlation coefficient just tells you how strong the data is, how strongly related they are. The correlation coefficient only pertains to linear relationships. Alright, if it's not linear, your correlation coefficient doesn't really tell you anything. Now, this crazy looking formula right here is the formula for the correlation coefficient. However, typically we don't use the formula. We just simply use technology like our calculator or our computer to calculate the value of R, the correlation coefficient. All right, so here's some important properties for your correlation coefficient R. Your R is always between -1 and 1. It doesn't depend on the units, like if you measured it in inches versus centimeters, something like that. It doesn't change. They're still correlated the same way. It doesn't matter which variable you let be x and which variable you let be y. It's just simply saying that these two variables are correlated. The order doesn't matter. Again, the correlation coefficient only measures the strength of linear relationships. If it's not linear, that correlation coefficient is not really telling you anything. It's not useful anymore. And the last one, just be careful if your data has outliers or anything in your data that could be that's skewing your data. Your correlation coefficient will like go with the skew. It will go with outliers. So it's very, very sensitive to outliers, and when you have those outliers, your value of R can be misleading. All right, so when you go to interpret your correlation coefficient, you have to remember that...
I wasn't able to understand the question I heard.
Alexa, stop. Sorry. When you're going to analyze it, if your R is positive, that means that you have a positive linear association. If your R is negative, then you have a negative linear association. If R is 0 or close to 0, then you have a very weak association. The closer that your R is to 1, the stronger it is. So like it's very, very strong and it's positive. If it's close to -1, it's very, very strong, but it's negative. If it exactly equals 1, then that means you have a positive slope and the points lie on an exact straight line. And when it equals -1, they lie on a straight line, but it's a negative slope. And again, if it's not linear, your correlation coefficient doesn't really tell you anything. You don't want to use it. All right, one key thing to remember, correlation does not mean causation. Just because two things are correlated does not mean that they're causing one another. You might see, for instance, you might be looking at data for the bathing suit sales in Florida in the summertime and versus maybe the ice cream sales in Chicago. Well, they might have a positive relationship. They might be correlated. Like as one goes up, the other one goes up, but they're not causing each other. All right, so again, you have to be careful. Don't assume just because two things are correlated that they're causing, one is causing the other one to happen. All right, so with all that being said, you have your scatter plot, you have your correlation coefficient. Now we want to look at our least squares regression line. Our least squares regression line is simply your best fit line. I know you guys probably heard of line of best fit from sometime again in like middle school. Well, that's your least squared regression line. The key to the least squared, though, why we call it least squares, is because it is the best fit line. It's not just any old best fit line. It's the best one. It's the one that reduces the difference between your points. So if I look at this distance, I'm calculating all these distances from the points to the actual best fit line. I'm picking the line that has the smallest difference between the points. All right, so our formula for writing our least squared regression line, we say is y hat. Y hat is the predicting value or the predicted value equals b naught plus b sub 1 x. B sub 1 is your slope and b naught is your y-intercept. Down here we have the actual formulas for b sub 1. Again, that's our formula for slope. And b naught, that's our formula for y-intercept. Guys, I know this looks crazy, like with all the b's and the x's and the y hat, but truth be told, it's the same thing that you've been doing for many years of math. Y equals mx plus b. Mx plus b. M was your slope, b was your y-intercept. It's the same exact thing, just written a little bit different. All right, so one key thing, or the main key thing that you need to know from your least square regression line is that it always goes through the average of all your x's and all your y's. Your least square regression line will pass through the average of both variables. So if you have a least square regression line, you know that your average is going to be contained on that line. If it's not, then it's not the least square regression line.